On February 12, 2024, the Eiffel Tower closed its gates in the middle of Paris, not because the wind was too strong, not because an elevator had failed, and not because the structure itself had suddenly become unsafe. Employees were on strike, raising concerns about the tower's maintenance and the scale of investment needed to preserve it. Reports at the time pointed to visible rust and a renovation program worth hundreds of millions of euros. The tower reopened 6 days later. Nobody was hurt. But the argument exposed something that photographs never show. The Eiffel Tower is protected by paint, inspection, and constant repair. Remove that cycle, and the iron beneath is vulnerable to corrosion. This is the Eiffel Tower. And here's what nobody tells you about how it's still standing. The reason this structure exists begins with a celebration. Paris was preparing for the Exposition Universelle of 1889, a world's fair designed to mark the centenary of the French Revolution and demonstrate France's industrial strength. The city wanted an entrance that would dominate the exhibition and make a very specific statement to the rest of the world. France could build bigger. The project was awarded to Gustave Eiffel and his company, with the design work involving engineers Maurice Koechlin and Émile Nouguier and architect Stephen Sauvestre. The brief was simple to describe and difficult to execute. Build a 300-meter iron tower on the Champ de Mars. The agreement signed in January 1887 gave Eiffel the right to construct and operate the tower, with a government subsidy of 1.5 million francs toward an estimated cost of 6.5 million francs. The tower was controversial before the first major pieces were assembled. A group of prominent artists and intellectuals signed an open letter objecting to the project, arguing that the proposed structure would dominate the historic character of Paris.
But construction continued. Work began on January 26, 1887. Just over 2 years later, the tower was ready. On March 31, 1889, Gustave Eiffel climbed to the top and raised the French flag. The structure that had been criticized as temporary was suddenly the tallest man-made structure in the world. And the engineering behind it was genuinely impressive. The Eiffel Tower contains 18,038 metallic parts held together by approximately 2.5 million rivets. Around 7,300 tons of iron make up the structure itself, while thousands more tons are involved in the total weight of the monument and its equipment. The tower was assembled from prefabricated components manufactured with extraordinary precision. Around 5,300 workshop drawings were produced. 50 engineers and designers were involved in the design process. At the factory in Levallois-Perret, around 150 workers prepared the pieces. At the construction site, between 150 and 300 workers assembled them. The final tower reached approximately 300 meters at completion. Today, with antennas, it stands at roughly 330 meters. It became a landmark. Then a radio tower. Then a television and communications structure. Then one of the most visited paved monuments in the world. The temporary exhibition structure became permanent. And then the engineers started doing the math. Because iron has one basic weakness. It rusts. In a normal building, paint is usually considered a finish. You apply it because you want the walls or metalwork to look good, and eventually you repaint because the surface looks tired. On the Eiffel Tower, that assumption doesn't work. The paint is part of the preservation system. Let's talk about what happens structurally when you leave exposed iron in an environment containing oxygen and moisture. Corrosion is the gradual chemical deterioration of a metal through reactions with its surroundings, and on a structure like the Eiffel Tower, the protective coating is the first line of defense.
Water reaches the surface. Oxygen reacts with the iron. Rust forms. The metal begins to deteriorate. And if corrosion becomes severe enough, it can reduce the amount of metal available to carry structural loads. That doesn't mean the Eiffel Tower is about to collapse. There is no evidence supporting that conclusion. In fact, the tower's official maintenance philosophy is based on the opposite principle: keep the iron protected, inspect it regularly, repair damaged areas, and repaint the structure before corrosion becomes a serious structural problem. Here's the thing about the Eiffel Tower that every conservation engineer knows. The tower doesn't need to be preserved once. It needs to be preserved forever. That changes the entire meaning of maintenance. The structure was built from puddled iron, a 19th-century material that is different from the modern structural steel used in most skyscrapers today. Its open lattice geometry also gives it an advantage. Air can move around the metal. Water doesn't remain trapped inside solid walls in the same way it might in an enclosed structure. But the tower is exposed. Rain, wind, pollution, temperature changes, birds, human activity. Every day, the same basic chemical process is waiting for the paint to fail. And that means the engineers designed a solution that sounds almost too ordinary for one of the world's most famous buildings. They paint it. Again. And again. The Eiffel Tower has historically been repainted roughly every 7 years on average. That maintenance cycle is closely associated with Gustave Eiffel's own recommendations. The tower has been repainted many times since 1892, with its color changing through different shades over the decades. But painting a 330-meter iron monument isn't exactly like repainting your house. The work is performed at height. Large areas have to be inspected. Old coatings may have to be removed. Surfaces must be prepared. Corroded sections must be treated. New protective coatings are applied. And weather conditions matter. During the tower's 20th painting campaign, which began in 2019, workers encountered sections carrying as many as 19 historic layers of paint. Think about what that means for a moment. The Eiffel Tower is not simply one color. It is a physical archive. Under the current coating are decades of previous maintenance campaigns, each one leaving another layer between modern Paris and the iron assembled in the 19th century. The 20th campaign was particularly complicated because of the scale of preparation required and the need to work around the tower's continuing operation as a tourist attraction. Workers used brushes and rope access techniques. They moved through the structure while visitors stood below them. A painter could be suspended hundreds of feet above Paris, applying a protective coating by hand to iron manufactured more than a century earlier. That part doesn't make it into the architecture magazines. But here's something about this building that nobody ever explains. The paint isn't the only thing that has to keep working. The elevators have to work. The restaurants have to work. The stairs have to work. The ticketing systems have to work. The electrical systems have to work. And all of those modern systems have to coexist with a structure designed in the 19th century. The tower's elevators are particularly important because millions of visitors depend on them. The lift systems have been repeatedly modernized and maintained, including major work on the North Pillar elevator and other systems connecting visitors to the higher levels. The structure also moves. All tall buildings move. The Eiffel Tower responds to wind. Sunlight heats the iron. Different sections expand at different rates. This produces small movements that are normal and expected. Not slightly. Not as a design flourish. The entire structure responds to its environment. But here's the detail nobody surfaces. A building that moves is a building whose maintenance has to account for movement. Connections must remain sound. Paint must remain attached. Inspection records have to be compared over time. And when you are dealing with a structure that has been standing since 1889, the problem is no longer simply whether the engineering was good enough. It is whether the maintenance system can continue for another century. Then came February 2024. The Eiffel Tower closed for 6 days during a strike by employees. Reports from the Associated Press described concerns over the tower's maintenance, including visible rust, while the operator had committed to an investment program of approximately €380 million through 2031. The event did not become a structural disaster. Nobody was injured. The tower reopened. But within 6 days, the conversation had moved from tourism to preservation. Within the next few years, hundreds of millions of euros would be required for renovation and maintenance. The problem wasn't that the Eiffel Tower suddenly stopped working. The problem was that keeping it working had become a very expensive, permanent responsibility. And here's the question that sits beneath all of this. What happens when maintenance itself becomes the greatest engineering challenge? Other famous structures have faced versions of the same problem. The Golden Gate Bridge in San Francisco must deal with corrosion from its marine environment and requires continuous inspection and painting. The Statue of Liberty has undergone major restoration projects to preserve its copper exterior and internal structure. The Brooklyn Bridge has survived through repeated rehabilitation and repair. The Forth Bridge in Scotland, another enormous metal structure, became famous for the constant maintenance associated with protecting its steelwork before. Each structure survived differently. Each had different materials, different environments, different engineering solutions. Here is the fundamental difference between the Eiffel Tower and every other historic iron landmark we've covered. The Eiffel Tower's survival depends on maintenance being treated as part of the building itself. Not an emergency response. Not a once-in-a-century restoration. A cycle. Inspect. Repair. Paint. Repeat. For how long? The answer is not written down. And that brings us to the uncomfortable part. The Eiffel Tower is more than 130 years old. Its engineers know how the structure behaves today. They have historical records. They have inspection programs. They have modern technology. But they don't have a second Eiffel Tower from 1889 that they can use as a perfect comparison. There is no historical data for what a 330-meter iron landmark looks like at 200 years, because no identical 330-meter iron landmark is 200 years old. This is the first. It is the only one. When engineers inspect the tower in 2030, 2040, or 2050, they won't be looking at a finished experiment. They'll be adding another line to the experiment. They will compare measurements. They will track corrosion. They will examine joints. They will monitor coatings. They will decide whether the current maintenance cycle remains sufficient. The engineers who work on the Eiffel Tower in 2050 will inherit the decisions being made today. And the engineers working on it in 2100 will inherit theirs. The tower's future is therefore not controlled by one dramatic moment. It is controlled by thousands of ordinary decisions. One inspection. One repaired connection. One layer of primer. One section of paint. Then another. Honestly, that's a little unsettling. Not because the tower is unsafe. Because it reminds you how much of the world's most permanent-looking architecture is actually temporary work being repeated forever. And yet, inside the tower, almost nobody thinks about it. Millions of visitors arrive every year. They queue beneath the iron legs. They hear the elevators moving. They feel the vibration as the doors close. They climb stairs where the metal handrail is cold against their palm. They look through the lattice and see Paris spread beneath them. In 2023, the tower welcomed nearly 6 million visitors as tourism recovered from the pandemic years. 6 million people standing inside a structure whose most important protection is something they can barely see. A thin coating. Paint. A guest might buy a coffee at the summit. A child might press their forehead against a viewing window. Someone might take a photograph of the Seine while a maintenance worker is somewhere above them, inspecting a connection that most visitors will never notice. The tower feels permanent. That is the illusion. The reality is more complicated. Its survival is not guaranteed by age. It is guaranteed by attention. By money. By inspection. By people willing to climb into the structure and keep doing work that will never make the front page. None of them are thinking about rust. They are thinking about tomorrow's shift. And perhaps that's how a monument survives. Not by being indestructible. By being maintained. Right now, someone is standing at the top of the Eiffel Tower, looking across Paris, unaware that the monument beneath them depends on a maintenance cycle that began more than a century ago. The tower isn't frozen in time. It is being continuously renewed. One layer at a time. The unasked question is how long that cycle can continue. Drop it below. Would you trust the Eiffel Tower to still be standing in another 100 years? See you in the next one. Verify. Eiffel Tower, located on the Champ de Mars in Paris, France. 1889, year of the Exposition Universelle for which the Eiffel Tower was constructed. Gustave Eiffel, French civil engineer and entrepreneur.